Consider this word problem on buoyancy. A solid square pine wood raft measures 4 meters by 4 meters by 0.03 meters thick. Determine if the pine wood raft floats in fresh water using buoyant force. And the density of pine is 550 kilograms per cubic meter. Well, the first thing we need to do is read this word problem and draw a sketch. So we have a pine raft, or a raft made of pine, and it measures 4 meters by 4 meters. So it's a square raft, 4 meters in one direction, 4 meters in the other direction, and 4 meters that way. And it has some thickness, 0.30 meters thick, something like this. So here's our raft, and it's floating in water. So we'll just draw some water, something like this. Here's water. And it's slightly submerged, not completely on top of the water, but some of it is submerged. And the dimensions of the raft is 4 meters one way, 4 meters the other way, and it's 0.3 meters thick. That would be this dimension here. And it says here to use buoyant force. Well, let's have a look at the equation for buoyant force. Here's our equations, and it says here the buoyant force is equal to the density of the fluid times the volume of the object times the acceleration due to gravity. So let's write that down. Looks like I'm going to need a new pen. So the buoyant force is equal to the density of the fluid times the volume of the raft itself, the object that's floating. And when I do volume, I put a V with a bar across it so it doesn't get confused with velocity. This represents volume times G, the acceleration due to gravity. All these are multiplied together. Having said that, let's see what's given to us here in the word problem. Well, we know the dimensions of the raft, the length times the width times the height. Well, that would give us volume. So we know what volume is. Volume of raft, or the volume of the object, is equal to the length times the width times the height. And we have that information right here. We can put in the numbers. 4.0 meters times 4.0 meters times 0.3 meters. And that would be equal to 4.80 cubic meters. That would be the volume of the raft, volume of the object. The density of the fluid, well, it says here we have fresh water. So the density of the fluid, in our case it's the density of fresh water. And you go back to our equation sheet, we have here the density of fresh water is 1,000 kilograms per cubic meter. And we also have G, and G is a constant, 9.8 meters per second squared. Next thing we need to do is look at the units. Make sure everything here is in base units. So we have cubic meters for volume, that's correct. And we have kilograms and meters for the density of the water itself. This would be the water that the object is floating in. And G, 9 points. So everything here unit-wise is good. But if we have a look here for a moment, okay, objects float because of density. All right, I'll make the comment here. Objects float of density. Rho, this is rho representing density. If the object is less dense than the fluid that it is resting in, it will float. If the object has a higher density than the fluid, it will sink. In our case, the density of the pine is given to us as 550 kilograms, and the density of the water is, we have it here as 1,000. So 550 is less than 1,000, so this will float. But the question is asking us to determine flotation here using buoyant force. In order to determine if this will float using buoyant force, we need to calculate the weight of the object, and weight always goes down towards the center of the earth. And I write weight this way, so the force of the weight is equal to mg, and it always floats downwards towards the center of the earth. And the buoyant force, that is a force generated by the fluid, and it pushes upward onto the bottom of the object. So force, the buoyant force, forces upward. If the buoyant force is greater than the weight, the object will float. If the weight, the force of the weight, is greater than the buoyant force, the object will sink. So now all we need to do now is calculate the buoyant force, calculate the weight, and see which one is greater to determine if this will float or sink. Having said that, we have the equation for buoyancy, the buoyant force. Let's put in the numbers now. Buoyant force is equal to the density of the fluid per cubic meter times the volume of the object itself, which we calculated to be 4.8 meters cubed, times g, doing this calculation, 1,000 times 4.8 times 9.8 is equal to 47,040. And looking at the units, kilogram or meters cubed is in the denominator and meters cubed is in the numerator. They'll cancel out. What's left is the kilogram meter per second squared. And this combination of units is also given the name of a Newton. And all forces have the unit of Newton. So the buoyant force is 47,040 newtons and pushing upward. We can reduce this now to proper significant figures. If we go back to our original word problem, we have here 2 sig figs, 2 and 2. We can ignore the density of the pine, but it also is 2. So we're going to reduce this to 2 significant figures. So buoyant force is approximately 47,000 newtons upward. Now we need to just calculate the weight. Now weight, according to our equations, we look back here, weight of an object, weight is equal to mg. Often I write weight as a force of weight is equal to mg, because weight is a force. And it has direction, it's always points down towards the center of the earth because of the value of g. Let's have a look here now. Well, I have already wrote it here. Thing we don't have is the mass. We don't have the mass of this pine. In order to calculate weight, we need mass. We know what g is, but we need mass. But we are given the density of the pine. So I'll just make a little comment here. Density of pine is equal to 550 kilograms per cubic meter. Can we use this now in order to find mass? Yeah, I think we can. We go back to our equations. We see here that density of an object or a liquid is equal to the mass divided by the volume. Let me write that down. In our case, we're talking pine, so the density of the pine is equal to the volume of the pine, the pine raft, and the mass of the pine raft. These are all the same object. Rearranging this equation in order to isolate mass, because that's what I want here, mass. Density of the pine times the volume of the pine raft, I should say, is equal to the mass of the pine raft, or the pine wood raft. So this density, or this mass, I should say, is equal to this one. I can substitute that with density and volume of pine. So the weight is equal to the density of the pine times the volume of the pine times G. This will be the mass I just wrote. Here's mass times G. We know everything here, so let's put in the numbers. Pine was given to us, the density is 550 kilograms per cubic meter. The volume of that pine raft we calculated to be 4.8 meters cubed times G, 9.8 meters per second squared. Doing this calculation, 25,872. It'll be newtons, so let's have a look at the units. They cancel out, so it's kilograms meters per second squared, and as I said earlier, this is a newton. So the weight is equal to, we'll use the whole number, 25,872 newtons. Since the weight is less than the buoyant force is 47,000 newtons. The weight of the raft is 25,000, therefore the raft will float. And this is, the weight always goes down. Therefore, raft will float.